Okay. I'm going to check if. Okay. Let me see if we are streaming to the grade 12. I'm going to do the monitor. Yes, cool. Coco, just for your sake, we are able to monitor all the ongoing streams as well.
Yeah. Marlies just came in and she's host now.
Hi, Marlies.
Hi, Lee.
Hi.
You okay?
I'm good. How are you?
Yo, no, crazy day, but sure.
It's been a crazy day, Shame. I'm sorry.
Shame, how are they doing with this geometry?
I think last lesson went pretty well. Hey, Coco, they seemed quite positive. There was one example that we did where they were like, that was difficult. But I tried to sort of just stick to, you know, well, when I say the basics, I mean, obviously still stuff that's fairly complicated, but just, you know, stuff that they really need to be able to do, to be able to prove similarity and write corresponding sides in proportion and then just make a sort of basic manipulation. So, yeah, it seemed to go well. They certainly were quite chatty and willing to come forward with answers and stuff like that. So not all of them, but a lot of them. So
yeah. Okay, cool.
Yeah.
So, Coco, you've got electricity.
I do. For some reason, it just didn't go away.
Right. Okay, I'm going to start letting people in, and I'm going to mute myself.
Thank you.
All right.
Yeah,
Thank you.
I'm going to make Coco host.
Awesome. Thanks.
Okay. Thanks, Marlies.
Bye-bye.
Hi, Matrix. Welcome back to lesson 4. It's nice to have you all with us again. Can you all hear me okay? Zanele, Ozayo, Noni, Chad, Benedict, all the usuals. Timothy, Jaden, Karabo, Swelile, welcome back. It's nice to have you with us. Who else is
everyone.
here? Hi, Neo. Hi, Swelile. Right, well, I guess just about everybody should be here by now. There's a couple more people in the waiting room. In the meantime, what I'd like you to do, hi, Chad. What I'd like you to do is have a look at the question that is in the middle of the screen, read the information that is provided, and then you're going to have a look at the first thing that they ask us to prove. Right now, remember, they're not telling us which triangles to work in. So it's our job to figure out which triangles we're working in before we get started on the question. All right, so I want you to think a little bit about how we're going to create TL squared and what that means. And then we'll get underway in just 1 minute. There's a couple of, I don't know if this is just people that are new or just new today. Noni is not a name I've seen before. Welcome, Noni, if you are new. And Iamik, I hope I said that correctly. That's also a new name. Miche, Have you been with us for a while? Meetly, I'm not familiar
No.
either. Is this your first time?
I started
Oh,
yesterday.
okay. All right, Meetly. Well, welcome. And yeah, I hope you enjoy our lesson. Unfortunately, you missed out on the first 3, but you should be able to fit right in and just carry on going with what we've been doing. We've already covered proportionality, intercept theorem, and its converse. And then in our 3rd lesson on Monday, we were talking about similarity and proving triangles are similar. So we're still kind of in that zone at the moment where we're proving similarity, and then we're going to talk about proving similarity using the sides rather than angles. But we'll get underway now, I guess. Hi, Noni. Are you also new, Noni? It's not a name I've seen before, unless I'm wrong.
But guys, remember, if you've missed any of these, you can find them on our website, watobe.co.za. All of them are uploaded there and on our YouTube channel as well.
Yeah. Awesome. Okay. Well, welcome, Nani, and I hope you really enjoy the lesson. Same to all the matrics as always. I'm here to help you. You can ask me anything that you like. If I've explained something and it doesn't make sense, please don't feel afraid to stop me and ask me to go back. No one is judging you. We are just here to try and help you understand and do the very best that you can. Okay, so I encourage you to participate and to ask as many questions as you would like to. Okay. All right, so let's get going. The bisector of K. Now, what does the word bisect mean? Nani, do you know what does the word bisect mean? You can put it into the chat if you want, if you don't want to unmute yourself. What is bisector? If something bisects something else, what are they telling us? Meets at 90? No, I'm afraid not. Okay, meets at 90 is perpendicular. So if they want you to say 90 degrees, they're implying that sign over there, that's perpendicular is the word that they use. Okay, but never mind, good guess. Okay, there, look at what Chad said, split equally, exactly. So bisect means to cut something in half. So cut in half. Yes, Karabo, exactly. Okay, so in English, bi means to, like bicycle, and then sect is to cut. Okay, so the bisector of K. So if they're telling you the bisector of K in triangle KLM, cuts LM, so here at H, and meets the circle circumscribing KLM at T. So in other words, KH is extended to T, to where the circumference of the circle is. Prove that. So it's not an awful lot of information that they've given us. But this bisector over here, what does that mean for us before we move on and try and prove this proportion? What are they telling us about K1 and K2? The bisector of K, what does that mean for us? K has been cut in half. So therefore, exactly, Chad. K1 equals K2. So what I'm going to do is I'm just going to call them both X for now. All right, good job. So again, we look at the question and we see that they have not told us in which triangles to work. All right, so we know that when they don't tell us in which triangles we need to work, we've got to go and find those triangles for ourselves, right? Remember from last time, you are not allowed to write on the page TL squared equals TK times TH as the first thing that you write, because that is what you are trying to prove. The first thing that you're going to write on the page is which triangles you're working in. That does not stop you from doing a little bit of rough work on the side. Okay, so you can label it as rough and then cross it out afterwards, but you don't even have to cross it out afterwards. So we're going to do a little bit of rough work over here. And this is us trying to figure out in which triangles are we working. So we go and we have a look at what they've given us. TL squared. Well, what does TL squared mean? What does TL squared mean for us? Karabo, do you know? What does TL squared mean?
Hi there. I'm not sure, ma'am.
It's okay, Karab, but you know what? Maybe it's one of those questions that's so easy that it's difficult, like we tend to overthink things. So if I said to you, what does x squared mean? What would you tell me?
Oh,
It means x times x, right?
yes, yes.
Okay, so x
Oh,
squared.
T and L together.
Exactly. So we always overthink things, don't we? I know, I'm also guilty of it. So it just means TL times TL. Now, the only way that we can get TL times TL is if we've got a TL at the top of one proportion and a TL at the bottom of another proportion. Okay, so that when we cross multiply, we get that TL squared. Then the TK and TH on the other side has to come from TK being the denominator in one proportion and the TH being the numerator in the other proportion. Is everybody cool with that? You see where it comes from? So TL squared comes from multiplying numerator and denominator this way. And TK times TH comes from multiplying denominator and numerator this way. Thumbs up, thumbs down, how are you feeling? Does it make sense? Does it make sense, Matrix? Really clear? Cool, thank you. Thanks, Sabashli. That's a nice smiley face. You did not think about that, though. I know. Someone's got to actually point this out to you. Thanks, Benedict. Thanks, Cesayo. Absolutely. So now if you do see that, then at least you know where it comes from, right? Now, thanks, Ayamide. Now, who can remember from the other day how we identify the triangles? There was two ways. How are we going to identify the triangles? What are our two options? Ayumide, can you remember?
Ma'am.
Yes, Karabo?
Don't we do it horizontally and vertically?
Absolutely.
Yeah.
Okay, so exactly. So sideways or around the outside. Okay, so we've just got to go and check what is a triangle. All right, so the first question we're going to ask ourselves, cool, yes, Ayumide, sideways. So in other words, this way and that way. We're going to ask ourselves, shouldn't do that first. Is TLH a triangle? What's the verdict, Matrix? Is TLH a triangle? TLH is a triangle. Okay, it's this little one over here. Yes, okay, so that's looking good. What about TKL? Is TKL a triangle?
Yes.
TKL is also a triangle. Okay, so now that we've got two yeses, I think we've identified the two triangles that we're going to work in. All right, and now we're going to scratch out or put a line through our rough work because we don't want that marked. Okay, that was helping us to identify the triangles we're working in. And now we're going to set out our proof for similarity. Okay, so in triangle TLH and triangle TKL. All right, we need to make three statements. Okay, remember we need to prove two angles, okay, and we're not allowed to use angles, interior angles of a triangle or angle sum and triangle as one of our first two reasons. Okay, it can only be our third reason. So we've got to think about other stuff. Okay, so does anybody, and now, hang on a second, before I talk about does anybody want to do anything, let me do this. All right, I'm going to highlight the triangles for you. Okay, so there is TLH, and you should do this for yourself as well. Oh, that is a terrible line. I'm so sorry. There we go. Okay, so there's triangle TLH in blue, and let's do triangle TKL in pink. I really need to practice drawing straighter lines, don't I? Hey, that is not great. But anyway, there we go. All right, so now that we've kind of made them pop out for ourselves, Okay. Let's have a look. Okay, remember the angles have to be inside the triangles. There's no point us talking about angle M or angle K2 or angle H2 because those angles are not inside our triangles. So I see something straight away. What does anybody else notice that we can use? Not LT, Nani, we're looking at, you're right, LT is a common side, but we want to prove similarity. So we're doing it by angle, angle, angle. So which angle do the two triangles share, Nani? Can't use K1 equals K1, but is K1 in the blue triangle, Chad? K1 is not inside the blue triangle. So we're looking inside the pink triangle and we're looking at, there we go. There we go. Nani's got it. All right, perfect. T is common. Good. Yes, Karabo, T is common. So T is common. Angle T is in both. It's okay. That's why you're here. No stress. Okay, now we need one more, okay? We got one more and then we can prove the last one by using angles of a triangle. Okay, so let's think very carefully. What else can we possibly use here? We know that K1 equals K2, right? You know that K1 equals K2, they told us that?
Same segments now.
That's it. All right. Who was talking? Sorry, I didn't see.
Swelihle.
Swelihle. Beautiful. What were you going to say, Swelihle?
L1 is equals to K2, angles in the same segment.
L1 is equal to K2, angles in the same segment. Perfect. Okay, lovely. So L1, can the rest of you see that? Equals K2, angles in the same segment. Okay, so if L1 equals K2, and we know that K2 equals K1. All right, so we can say K2 equals K1. That was given to us. So therefore, angle L1 equals angle K1. All right. Well done, Swelihle. Well done, Nani. Okay, that's great. And now we can do the remaining angles using angle sum and triangle. Okay, so the remaining angles in this case are going to be angle H1. Let's just put that in. Okay, so third reason. Okay, is KLT, angle KLT, that's the whole angle, is equal to angle H1. Okay, remaining angles of a triangle, or angle sum and triangle, or sum of angles in triangle, whatever floats your boat. Okay, so therefore now, before I start writing, what do I need to be very careful of in this line? Exactly, Chad. All right, so Chad, why don't you give me some order here? Tell me what to write. Are you okay, Chad? You okay to do it? Oh, that's okay. You're not, I don't know, maybe your internet connection is slow, but you're certainly not slow. Do you know what you can do? Keep the TLH that you had first written down, keep that the same. And then go is similar to triangle, all right? So angle T is common. So if it starts with T in the first triangle, it must start with T in the second triangle. Then we've got L next. L went with H. Can you see over here? L and H went together, so I've got to put L next, because L and H went together. Oh, no, hang on. Sorry, I'm talking nonsense. TLH, yes. So, sorry, it's K. Ugh. L and K, sorry, L and K went together. And then the last one, H in the one, went with L in the other. All right, so this has got to be L over here. Okay, and reason, angle, angle, angle. Okay, so it's really important. This over here that you've written, your 1, 2, 3, that will guide you as to the order. Okay, so you're looking here as to guide you as to the order of these. All right, and that's really, really important because all our proportions come from that. Okay, so now I'm going to get you guys to make the proportionality statement for me. Okay, what am I going to write? This is the first and last, or first and second, second and last, first and last that we were talking about the last time. Deneo, do you want to do it? You feeling shy, Deneo? Okay, can someone help Deneo? Okay, that's fine. All right. Come, Matrix, you're going to have to do this for yourselves in your exam. So help me out here. What should I write? Even if it's not correct, it's not the end of the world. Just give me somewhere to start. Jaden. Are you feeling shy today, Jaden? TL over TK. Perfect, Benedict. Thank you. So TL over TK. Good job. See, the first two over the first two. Actually, yes. Okay, that's fun. Then I won't pick on you either. Benedict, you're onto something good here. Keep going. Keep going. I'm liking it. TL over TK equals?
LH over KL.
LH over KL. Beautiful. Keep going. Keep going. Don't stop.
TH over TL.
Nice. Okay. And what are we going to TH over TL? Thanks, Chad. Yes, perfect. And what are we going to write as our reason over here? Can you remember, Chad? Can you remember, Benedict? What's our reason? Yes, good. Corresponding.
Corresponding sides in proportion.
You smashed it, Benedict. Well done. Corresponding sides in proportion. Lovely. Okay. And now, do you remember how last time we went and we worked with colors? Okay. Yeah, Benedict is smoking hot today. Hey, Chad. All right. So we need TL and we need TL and we need TH. I'm just going to move that down like that, and TK. All right. So now let's go and get some colors. So bright blue, we need TL and we need TL, and we need TK and we need TH. There we go. All right, so we're going to take that. Just move it. Whoopsie. This one is giving us more than enough space to write here, but anyway, it doesn't matter. Okay, and now we're going to take TL over TK equals TH over TL. And now you're just going to cross multiply. Okay, and therefore TL squared equals TH times T. Okay. All right. How do you feel? Does that make sense? Is that easy enough? It's very similar to what we were doing last time. Just we didn't look at any squares. How do you feel, Matrix? Just need a reminder. Okay. All right. And some practice. Hey, Chad. Okay, good. Hello, Atin Corsi. Welcome. Nice to have you here. Amazing. Oh, Karoba, I'm so happy. That makes me feel all warm and fuzzy inside. I'm glad. Cool, Benedict. Thank you. Yes.
I wanted to ask, how many marks would this question be?
Mihle, that is a very good question, actually. And I would say something like this would probably have to be out of, you'd probably have 2 marks for the similarity. And then for the side, maybe out of 4. Out of 4, because I mean, first you've got to prove triangles similar, and then you've got to write the corresponding sides in proportion and then go from there. So yeah, I'd say about 4 marks. Okay. All right, let's have a look at the next part of the question. Okay. So now they give us another proportion that they want us to prove. So KH times LT equals Km over LH. All right. So now again, have they told us which triangles they want us to work in? No, they haven't. All right. So if they don't tell us which triangles we're going to work in, we have to go and find those triangles for ourselves. Okay. Now, again, you're allowed to do a little bit of rough work on the side. You are not allowed to write KH times LT equals KM times LH as the first thing on the page. All right, that is what you are trying to prove. All right, so where does KH times LT equals KM times LH come from? It comes from a proportion statement. Okay, so just like we made a proportion statement in the first one using the TL squared equals TK times TH, I would like someone to tell me how I should write the proportion statement for what we see in question B. What should I write here? So my rough work, what should I write? Any ideas? Okay, so Chad says KH over KM equals LT over LH. Okay, Benedict says something different. Benedict is saying KH over LM, sorry, KH over LH, sorry, is equal to KM over LT. All right, so let's have a look. So we want KH times LT. So KH times, so now can you see, unfortunately, Chad, that's not going to work because remember, you are only allowed to cross multiply. So when you cross multiply over here, you're going to get KH times LH, and we've got KH times LT. So here, Benedict, what you've suggested, KH times LT, that's looking a little bit better, okay? Because now at least we've got what we want on the left. Are we going to get what we want on the right? Well, yes, because there's your KM and there's your LH. So this one is working really nicely. Well done, Benedict. Good answer. Okay, so now again, now that we have our proportion, we have to identify the triangles that we're working in. So left and right or around the outside. Okay, so go back and let's have a look at the diagram. And the first thing that we want to ask ourselves is, if we go side to side, is KHM a triangle? Is KHM a triangle? What's the answer to that, Matrix? Is KHM a triangle? Yes, indeed it is. Yes, Nani. Yes, Rekhomoditswe. Cool, it is. It is indeed. All right, so if I went left and right at the top, Rekhomoditswe, what must I do at the bottom? If I went left and right at the top, I've got to go left and right at the bottom as well. Okay, so now I'm just checking, is LHT a triangle? And what's the answer to that? Yes, indeed. Okay, there we go. All right, so now we know in which triangles we are working. Right, and what I'm going to do, just to clear a bit of space here, is I'm just going to rub out everything. Have you written it all down? If you were going to write it down, I can rub off what we had done in 7A, just so that we can write in the same place. Is that okay? I take it that everybody's happy with that. Okay, so let me just rub this out. And I'm going to rub that out as well. And then we can always put back what we already know. There we go. Just get rid of it. There we go. Okay. All right. So now that it's all rubbed out. Don't know if we're going to need this for this question. Let's just put it back in just in case, and we'll write in pink so it's nice and bright. Remember, those two angles were equal to one another. Okay, so we identified KHM as a triangle, so I'm just going to color that one in. You would obviously color this in using a highlighter. I'll try and go a bit straighter this time than I did the last time, although in my case, practice doesn't seem to be making perfect. And then LHT. So that's this triangle over here, isn't it? LHT. So now remember, matrix, we can only work with angles that are inside the pink triangle or angles that are inside the yellow triangle. Okay, and we actually already know that that angle over there is equal to X from the previous question. Okay, so again, setting it out in the correct way, we have to write in triangle KHM. Oopsie, triangle KHM and triangle LHT. Okay, number one. All right, so let's call on someone. And I mean, if you don't feel comfortable to talk, then that's fine. Neo, what about you? Oh, Rekhomoditswe, perfect. Perfect. Well done. Thank you. That's excellent. Good spot. Okay, do the rest of you see that in the chat? Rekhomoditswe has said H1 equals H2 vertically opposite angles. Nice and easy. Perfect. So H1 equals H2 vertically opposite angles. Good job, Rekhomoditswe. Lovely. Okay, so first one down, next one. This is actually very simple. We've actually already got the answer in front of us. Swelithli, I think you pointed it out to us the last time. L1 equals K2, exactly. Yeah, exactly, Nani. Quite right, Karabo. Okay, good job. Well done. All right, so L1 equals K2. We could say proved above because we have proved it above, or we could say angles in the same segment. So I'm just going to say angles in the same segment. And what does that leave over for us? Right? So angle T and angle H. Angle T and angle M. Yes. Okay. So now, Chad, you could say that angle T equals angle M, and you could say one of two reasons. What are the two reasons you could say? Spartley's given you a hint above. T and M are? Yeah, sum of angles in a triangle, absolutely. Okay, or can you see there are also angles in the same segment? Can you see that, Noni? Can you see that, Chad? Yeah, angles in the same segment. So it doesn't matter. You pick. Okay, Noni, pick one. Which one are we going to go for? We're going to go for angles sum and triangle, or we're going to go for angles in the same segment? Okay, all right, angle sum and triangle. Excellent. Okay, so therefore, now again, be careful. We've got to get the order right. So if we go KHM, all right, K went with L, so I've got to put L first. H went with H, so H has got to go next, all right? And M went with T. Okay, so triangle, LHT, angle, angle, angle. All right, and now again, can you see how repetitive this actually is? All right, so proving similarity and then again writing down the corresponding sides in proportion. Okay, so Benedict was a champ the last time at that. Does anybody else want to tell me what I should write? Remember, we're writing our proportion statement, okay? The corresponding sides in proportion. So get me started. Okay, all right, Noni's going. All right, KM, hang on, Noni. KM over LH, you said. Yes, good. Equals. Chad says KH over LH. Same thing. Perfect. Well done, guys. Equals. HM over HT. Lovely. HM over HT. Good job. Equals. Last one. Indeed. Okay, so KM over LT. Reason, corresponding sides in proportion. Okay, let's just move this up a little bit. Okay, now what did they want from us? They wanted, let's just clear this from the previous time. They wanted KH times LT and KM times LH. Okay, so again, let's go and get some color and let's highlight the ones that we want. Okay, so let's get some pink. So we want KH, right? Where do you see a KH? Did we, oh, you know what? It's me. Ugh, silly. That's supposed to be KH. Sorry, guys. There. So KH was the first two. So, okay, so there we see a KH, all right, and an LT over here, and a KM over there, and an LH over here. Okay, so it happens to be those two again. All right, so KH over LH equals KM over LT. And now they want us to cross multiply. Okay, so therefore KH times LT equals KM times LH. Okay, matrix. Does anybody have any questions? How are you feeling? Is this making sense? Do you think you'd be able to answer these questions if it came up? Do you feel better about it? Talk to me. Good. Okay, thanks, Cheeto. I'm going to call on you in the next one. Okay, Cheeto? You're actually understanding. Good. I'm so glad. Makes much sense. Good, Spathe. Feeling a whole lot better, Swelithe. Good. I'm glad. I'm glad. Better. Okay. All right. So we've spoken about if they tell you which triangles to prove similarity in, they're basically giving it to you on a plate. We've spoken about that the last time. Better. Thanks, Ozayo. Nice to hear from you. And then we've spoken as well about if they just give us a proportion, how we would then find the triangles to work in. Okay, and that's what we've spoken about now. All right, so let's carry on and let's just speak a little bit. Oh, that was from the other question. Let's just speak a little bit about the converse of the equiangular triangle theorem, because it's actually very easy. And a lot of people really struggle with it, and it's really not that hard, okay? Do you remember in our lesson the last time, we said that there were two ways to prove similarity. So either we prove angle, 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 which is what we've been doing up till now, or we can prove that the corresponding sides are in the same proportion. So if you have a look at example 4, they tell us that PQ lies on sides X, Y, and XZ respectively of triangle XYZ. And now they give us some sizes. So they tell us that XY, all right, so let's just get some color here. XY is the whole thing, okay? So XY is 25. XZ, let's use a different color, is 30. Then they tell us that YZ so that's this one over here, is 20. Also, XP, so let's put XP over here. XP is 24. And PQ is 16. And XQ, so that's this one over here, is 20. Okay, so can you see they have given us no information about the angles? All right, so in this situation here, the only thing that we know is that angle X is common, but we don't know anything about the other angles. So the suggestion here is, because they've told us about the sides, they want us to use the sides in proportion. Okay, so now we've just got to figure out how we're going to set this up. Okay, so it's going to be a side over a side, and then we're going to sub in the numbers, and then we're going to simplify the proportion. Okay, so now we've got to figure out which sides actually go together. All right, so if we start with side XY, let's make it a better color than that. That's a bit insipid. Also, is that big enough? Can you guys see okay? I'm just trying to make it a little bit bigger. So if we start with XY, how would we know what to put underneath XY? Is there a clue or a hint that we can use? Have they actually told us the answer? We just need to know where to look. Does anybody know?
XY over XQ.
Exactly. Perfect. Okay, because it's first 2 over first 2. Exactly, 100%. So XY over XQ. Beautiful. And now we are going to sub in what XY is. Remember, XY is 25 and XQ is 20. And when we simplify that, yes, exactly, Swelihle, we just got to know where to look. The answers are right here in front of us. Okay, so first 2 over first 2. Second 2 over second 2. First and last over first and last. All right, it's right there in front of you. Just like when they ask you to prove that they are similar, but using angles. Okay, so 25 over 20 is going to simplify to what? Matrix 5 over 4. Indeed, cool. Why are you saying oops, Bahle? You're right. Or is it because you didn't know that? But at least now you do if you didn't know that before. Okay, now the next one. Okay, let's go with purple here. Swelithle, why don't you make the next one for us?
YZ over QP.
Beautiful. Okay, cool beans. YZ, how long is YZ? YZ is 20, isn't it? Yes. Over QP is 16. Okay, and again, divide by 4, divide by 4. We get 5 over 4. All right, and now the last one. Okay, so we're going to go first and last and first and last. Okay, so XZ over XP. All right, so XZ in this case is, XZ we said was 30, and XP was 24. Okay, so again, divide the top by 6, the bottom by 6, and we end up with 5 over 4. Right. What I want to emphasize here is, please note, I did not start YZ. So Nani's saying YZ. So do you mean because of XZ? Is that why you're saying YZ? You mean, but why is there a Z here? It's this side over here. So what we're doing, Nani, is this. First and last over first and last. Okay, so the black one is the first 2 over the first 2. The purple one, you wanted to use P and Q. We've already used PQ. PQ corresponds with YZ. Right, so you've got to look at the order that they give you, Nani. Everything is, when they give this to you, they're literally telling you which sides are corresponding, and they are telling you which angles are equal. All right, so in this question, let's just change the color here. I don't think the others will mind me emphasizing this, well, at least I hope not. So we've got X, Y, Z. Sorry, I write my Z's like that because my Z's look like 2's. Similar to triangle XQP. Okay, so Nani and everybody else, they are telling you that XY corresponds with XQ. See there? Okay, first 2 and first 2. They are telling you that YZ and XP correspond with one another. Okay, look at what we wrote in purple. And then first and last, they are telling us that XZ over XP, that they are corresponding sides. Okay, yes, exactly. So when it's given, Nani, that is how you do it, all right? Also, if you were going to prove similarity using angle, you can also use this as a clue. They are telling you that angle X equals angle X, and so it does. Can you see here? X is common, okay? Angle Y will be equal, so this angle over here, angle Y will be equal to angle Q, right? I mean, we obviously don't have the information to prove that, but if we did, and then angle Z over here is equal to angle P over there. Okay, so the order in which they give it to you is the clue. Now that you've proved that all corresponding sides are in the same proportion, now, matrix, you are allowed to conclude. Therefore, okay, let's just make some space here. All right, so therefore, pink. Okay, therefore, XY over XQ equals YZ over QP equals XZ over QP. I did get that right. So XY over XZ, YZ over QP, XZ over XP. Okay, so therefore, triangle XYZ is similar to triangle XQP, and that is because the sides or corresponding sides are in proportion. Okay, how does that feel? It's actually quite easy, isn't it? How do you feel, Matrix? Much better. Okay, Cheetah. Cool, Swelithle. Thanks, Chad. Okay, that's good, Benedict. All right. Cool. Thanks, Rekomeditswe. Thanks, Ayomide. Okay, so let's have a look. Cool, Nani. Let's have a look. So this is just the converse of the equiangular triangle theorem. That's exactly what I've just shown you. All right. So if AB over PQ equals BC over QR equals AC over PR, it means that angle A equals angle P, first and first. Angle B, second and second, equals angle Q. Third and third, angle C equals angle R. All right, so here we've proved it by sides and proportion, and the deduction then is that those angles would be equal. Do you see how these two are the converse of one another? They work in opposite ways. So either we prove angle, 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 and then we deduce that the sides are in proportion, or like we've just done now, we've proved that the sides are in proportion, and then we deduce that the angles are equal. Okay, and both of those prove that triangles are similar. Okay, so like in the next question here, okay, we're going to move on to this exam question now. Hupstad out of 2019 paper, because I thought it was a really cool question. But we'll do that now. Okay, so let's have a look at this one. When they give you the lengths of sides, they are dropping massive hints that you need to do. You need to prove similarity with sides and proportion. Okay, so just like what we've done now, okay, again, read the clues. They've told you which triangles to work in. So that's really nice because they've actually already told you which are the corresponding sides. Okay, so now without me telling you, I'd like you to tell me, what should I write in A? What's my starting point? So after I've obviously written in triangle STP and triangle QRS, I'm going to look, can you see they've told us? So QR is 9,6, TP is 4,5. I suppose we can put those values in. So TP is 4,5. What is that? QR, where's QR? Oh, there we go. QR, and there, that's 9,6. PS is 1,5. SR is 12. SQ is 4. And TS is this one over here, is 3,6. Okay, so I would like one of you, please, to tell me where I would start. I'm going to prove that these triangles are similar using corresponding sides and proportion. So what over what?
ST over QR.
Lovely. ST over QR. Swelithle, sub in for me, please.
3,6 over 9,6.
Lovely. And 3,6 over 9,6 leaves us with how much? ST over QR. Yes, that's good, Benedict. Well done, Chad. What's 3,6 over 9,6? What does that leave us with? Anyone manage to simplify it? Sorry, I don't actually have my calculator here, which is not awesome, but anyway. I suppose essentially what we're doing is we're doing 3/8. Yeah, because it's how many times does 36 go into 96? Yes. Good, Neo. I agree. It's 3/8. Yes. Okay, good job. What's the next thing that we're going to write? Okay, so Swelihle has given us an option. Neo, are you feeling brave enough to tell us what you think? What over what, Neo? Chad says TP over RS. Good, Chad. TP over RS. Okay, so now again, we've got to sub in. Okay, Chad? Yes, Neo. TP over RS. So what's TP, Neo? TP is? Good. And RS? Good. Well done. Okay. And again, guys, if you put that into your calculator, so 4.5 over 12, fingers crossed, it gives us 3/8, does it? 3 over? Okay. 3/8, Karabo. Thanks, Neo. 3/8. Okay, so you go 4.5 over 12. Right, yeah. 3/8. Good. So now we know that we're on the right track. Okay, last and last.
PS over QS.
PS over QS. Yes. SQ doesn't matter. Yes, SP over QS. Good job. Okay, so what's SP in this case? It is
1,5.
1,5. Indeed, it is. And what's SQ?
It's 4.
It's 4 indeed. Okay. And again, fingers crossed that that gives us 3/8. Check quick. Does it? Yes. Neo says yes. Nice. Okay. And now therefore, matrix, we are allowed to conclude what? ST over QR equals TP over RS equals PS over SQ sides in, oh no, hang on, sorry. That's not actually where I should write that. I want to write it next to my similarity. So therefore, triangle STP is similar to triangle QRS sides in proportion. Okay, so can you see how we've just used that converse equiangular theorem in our first answer here? Yes, Sabathi, ask away, yes.
Can I ask, ma'am, like when do you use the corresponding sides in proportion reason?
Okay, so Spatle, either they will be giving you information about the angles or they will be giving you information about the sides. Okay, so when they give you information about the angles, then go with angle, angle, angle. If they tell you the lengths of sides, then you're going to go with corresponding sides in proportion. Okay, so what you'll find is that a question won't muddle those two up for you. All right, you won't get all the sides and all the angles. All right, it will be really specific. So either you'll know about the sides or you'll know about the angles. Okay, so it's going to be one or the two. Okay, Spahle?
All right, thank you, ma'am.
Okay, no problem. Any other questions before we carry on? So what this means for us, yes, when you say yes, Neo, do you have a question? Or is that just yes to what I think you were saying yes to the 3/8, I think. Okay, let's go back. Now, angle S and angle Q are equal. Okay, angle S, we don't know angle S what. STP, STP P is that one. Okay, so angle S. So that angle S over there, and angle Q, QRS. So that has to be that angle over there. Right, those two are equal. Angle S and angle Q are equal. Angle T and angle R are equal. Let's use a different color. Angle T and angle R are equal. And let's use a different color, purple. Angle P, which is that one over there, and angle S are equal to one another. Okay, so there are our two similar triangles. Now what they want us to do, Matrix, I'm just going to take the lengths of the sides off now because we've finished working with those, all right? And I'm going to leave the angles that are equal to one another on there. Now they want us to prove that PT is a tangent to the circle. PT is a tangent to the circle TSR. So this is our grade 11 work coming through. Okay, can you see now how when you get to matric, the grade 11 and the grade 12 stuff is now firmly intertwined. All right. So now we've got to go back and think about how did we prove that lines were tangents to circles? Can anyone remember? There was one sort of outstanding way in grade 11 how we would prove that a line was a tangent to a circle. Can anybody remember what that was? No one? Okay, so if you want to prove that a line is a tangent to a circle, one of the ways that you can do this, sort of the most obvious or often tested way, is to use converse tan chord theorem. If you've heard of that, I want you to put a thumbs up on the chat for me, please. If you've heard of converse tan chord theorem, put a thumbs up. If you haven't, put a thumbs down. Thanks, Willie. Thanks, Karen. Okay, Ayomide. Cheeto says yes. So thumbs up for yes, you've heard that, or thumbs down for no, you haven't. Thanks, Mikle. Thanks, Chad. Okay, Rekomeditswe. Thanks, Benedict. Sparkly, yeah, but never understood it. Sure, fair enough. Okay. It's a question that often comes up, actually. It's like them getting you to prove that a quad is cyclic. They will definitely ask you to prove that a quad is cyclic in your upcoming exam. There's no doubt about that. Whether they ask you to prove that a line is a tangent to a circle, they may not. But definitely proving a quad is cyclic is something that will come up. But this is also, it's a very commonly asked question. So let's just talk a little bit on the side about this, and then we can come back and we can have a look at the diagram and see what it is that they're talking about. Okay, so if we have, let's try and use our shapes here because their shapes are probably going to be so much better than mine. Okay, those are straight lines. Hang on. Shape, circle. There we go. That's a much nicer circle than I could have drawn, isn't it? Okay, so there's a circle, and let's get a tangent. There we go. And let's get how. Why is that line like that? No, I don't want that. I want that. And now, there we go. Thank you. I'm going to put that over there. And then I'm going to draw another line. from here to there or wherever. And then last line matrix, hang on 1 second, from here to here. Okay. So let's just give these things some names. I'm going to call that A, B, C, D, E. Okay, so if ABC is a tangent to circle EDB, then 1, 2, 3, then, for example, angle B1 will be equal to angle E tan chord theorem. Okay, so that's how tan chord theorem works, right? So the angle between, now you've got to look very carefully, okay, matrix, the angle between, okay, the tangent, here's the tangent and the chord. So now you've got your fingers at B and D, and then you're going to trace B and D back to the same point on E. So you're going to drag your fingers up here. There's the angle in the alternate segment. Okay, that is tan chord theorem, right? What we are talking about is converse tan chord theorem. So tan chord theorem says if a line is a tangent to a circle, then the angle between the tangent and the chord is equal to the angle in the alternate segment. Converse tan chord theorem says the opposite. Okay, so now what I'm going to do is I'm going to rub this off.
Ma'am, can I ask a question?
Yes, Bartley.
Ma'am, is it correct to give a reason saying exterior is equal to opposite interior?
Yes, you can do that, but then what you're doing is you're actually talking about cyclic quads. You're not talking about tan chord. Okay, exterior angle equals opposite interior angle is another way of saying the exterior angle of a cyclic quad is equal to the opposite interior angle of a cyclic quad. So it's not tan chord theorem, it's one of the other theorems.
Thank you, ma'am.
Okay, no problem. All right, so now if we are able to prove that B1, so if B1 were to equal E by some other methods, then we would be able to conclude that ABC is a tangent. And our reason for proving that it's a tangent, we've got to state these angles that prove it. Then we would say converse tan chord theorem. Okay, so tan chord theorem does one thing and one thing only. It proves a line is a tangent to a circle. That's the only thing we use it for. Right, it doesn't do anything else. So more than likely, in this case, we need to prove converse tan chord theorem. Now that means, matrix, it means identifying the angle that would be the angle between the tangent and the chord, and the angle that would be the angle in the alternate segment. And that's the hard part, because like with so many of these diagrams, there are no circles drawn. So you're doing this without the circle even being there. Okay, so PT is a tangent to the circle. So here's TP, which is your tangent to the circle. Okay, so TP is the tangent to the circle. So that means that angle T1 has to be the angle in the alternate, has to be the angle between the tangent and what would be the chord. Now, can you see, put your fingers at T and at S, and now follow T and S all the way to R. Can you see that? T1 equals R. Exactly, Karen. Exactly. That's exactly it. So T1 should equal R, Chad. T1 should equal R. Oh, R. Can you see it now? So TP, I don't know if I need to turn it around for you, but TP is the line that's going to be the tangent, okay? TS is the chord inside the circle, the make-believe circle. And then with our finger at T and our finger at S, we're going to trace it to the circle. R is at the circle. Can the rest of you see that? Karen, you seem to get it like that, which was really nice. How does everybody else feel? Okay, Sbahle, you said you never understood this. Am I still losing you?
Ma'am, I'm lost. Can you please explain?
Oh, I'm sorry, my darling. Okay, so now there is a make-believe circle. Okay, it doesn't actually exist. All right, and they've called it TSR. So what that means for us is that this circle, let's just see if I can do this. Hang on. Okay. Okay. Now, the circle that I've just drawn, Sparche, did not exist. Okay, so whether the circle is there or not is irrelevant. Okay, but you have to imagine that that circle that I've just drawn for you is there. Okay, let's make it, because it's in it. Wow, no, I didn't want to change that. There we go. I just wanted to make it a different color. There we go. Let's make it, what are we going to make it? Green. That one. Okay. There. Okay, so that green circle is imaginary. It isn't actually there, but that doesn't matter. All right. The line that we are trying to prove is a tangent to the circle. Is this line over here PT? PT, if PT is a tangent to the circle, we need to prove that the angle between the tangent and the chord, in this case, it would be angle T1, is equal to the angle in the alternate segment. Right, now can you see from similarity, we proved angle T1 equals angle R, didn't we? We proved it from similarity. So because we've proved T1 equals R, because triangle TPS is similar to triangle RSQ, that means that T1 equals R. So if T1 equals R, it means that PT is a tangent to the circle, converse tan chord theorem. Sparkle, yes, no?
Yes, ma'am, I do get it. So, ma'am,
you,
TS is the chord.
TS would be the chord, exactly. Exactly. All right. And TP is the would-be tangent. Okay, TS is the would-be chord, and angle R is the would-be angle in the alternate segment, and angle T1 would be the angle between the tangent and the chord.
Thank
Okay,
you.
does that make sense now? Can you see it now? Obviously, now this one is sort of lying on its side. It's not sort of upright like it was before.
So,
but
the perfect way is to draw the circle.
Well, you can if you want to, but I mean, that's it's difficult to draw the circle. I mean, you can see, like, I'm lucky now because, you know, I have a circle on my thing, and then I can, but the idea is to try and identify. So what you are looking for is this shape. Okay, just, I'm going to go to the side again. So using that, okay, you are looking for this. Okay, you want, why am I clicking on that? I have no idea. You are looking for a come on, Lee. You are looking for a triangle. Okay, and then a line off the triangle like that. So it's a line with a triangle attached to it. And if you can prove that this angle over here equals that angle over there, then you've proved that this line is a tangent, to the circle going through the 3 points of the triangle.
Thank you, ma'am.
Okay, is that making more sense now?
Yes, ma'am. Thank you.
Okay, all right. So that's essentially what we are doing. Now here, our triangle is kind of sitting up. Yes.
Ma'am.
Yes, me.
So when we have to prove, is the reason converse tan-chord theorem? If we say tan-chord theorem, would it be wrong?
If you say tan-chord theorem, then that would be because they told you that the line was a tangent to a circle. So you can only prove that a line is a tangent to a circle by using converse tan-chord theorem. That's the only thing it does. That's the only thing converse tan-chord theorem does. It proves that a line is a tangent to a circle. Okay, so if I just put this into sort of context for you, let's just go back to this and go and have a look. All right, what I would do, all right, is that based on my answer from A, I hope this is big enough and you can all see it, but I don't really want to rub this out. But based on my answer from A, now in B, all right, I can conclude. Remember, I had said to you, angle S, so the first angle here and the first angle over there. Okay, so S and Q, the red ones. T and R, can you see the yellow ones? P, the purple one, and S, the yellow one. From this, I can conclude, all right, that angle T1 equals angle R, all right? And this is because I have proved triangle STP similar to triangle QRS. So now that I've proved T1 equals R, therefore I can conclude PT is a tangent and my reason, converse tan chord theorem. That's supposed to be an R, by the way. Okay. What do you think, Matrix? How do you feel about that?
Ma'am.
Yes, Mihle.
Ma'am, so when we also have to prove for a cyclic quad, the reason would be converse of cyclic quad.
Yes, absolutely. So when you're proving a quad is cyclic, it's either converse angles in the same segment, converse exterior angle of cyclic quad, or converse opposite angles of a cyclic quad are supplementary.
Okay, thank you.
Okay, it's a pleasure. It's a pleasure. How's everybody else feeling? How are you feeling, Matrix? Thumbs up, thumbs down. Thanks, Bahle. Hopefully better than it was. Thanks, Timothy. Oh, you're being low. Who's? Oh, that's nice. 100% from Chad. A lovely smile from Karabo. Thank you, guys. Benedict. Oh, good. All right. So there's some happy Matrix on the other end. Okay, that's what we want. Okay. All right. Let's go on to the next question. Yes.
Ma'am? Sorry,
Yes.
can you please repeat what you just said to Sparkly about the tangent?
Are you talking about proving that a cyclic quad, proving that a quad is cyclic, Karabo?
No, I meant the tangent. I thought you were talking about proving the tangent.
Okay, so what I was saying here, right? So in question B, I was saying that because we proved triangle TPS similar to triangle RSQ, that meant that angle T1 was equal to angle R. So if we drew a circle through TSR, the green circle, we could prove that PT is a tangent to that circle because T1 equals R, all right, from similarity.
Okay.
Therefore, PT is a tangent to the circle, and that would be converse tan chord theorem.
Oh, okay, ma'am. Thank
Okay,
you.
that's what I was saying. All right, so we've just answered
Alright.
question B. Okay. All right, let's get on and answer question C, because this is also the sort of thing that they would ask us. What are they asking us to do in question C, Matrix? They want us to prove that lines are parallel. So in other words, that QS, this line over here, is parallel to TP. Okay, so now this goes back, because we've had 4 lessons now. This goes back to our second lesson. And now you're going to see how the converse of the proportionality intercept theorem comes into play over here. So, starting with question C, okay. Actually, hang on a second. There's an even easier way to do that. We don't even need to do it that way. Look here, I've just looking at the diagram now, I've just spotted it. I was being dopey. Matrix, look at the purple angles. Yeah, exactly. Exactly. Okay, so because angle P equals angle S3, also from similarity, also proved by triangle STP similar to triangle QRS, that means that, let me just move this up a little bit. That means that now I move it up and now I don't know what the PT QS parallel to TP. QS parallel to TP. And my reason here is because corresponding angles are equal. Okay, so if corresponding angles are equal, lines will be parallel. Yes.
Ma'am?
Yes, Bartley.
Ma'am, can you say QS is parallel to TP and the reason could be line drawn from center of a triangle?
Parallel line drawn from center. But you see, we don't know that we've got a center though, Sabahle. Okay, we don't know. We don't know that we haven't been told that we have a center. So we don't know if Q is a center. They haven't told us that. So we must be very careful about making assumptions. All right. So unless they've told us that something is true or we can prove that it's true, stay away from assuming things are true. All right, because that generally leads to problems. Yes, Karabo.
What about, I don't know, but what about Q2 and S1 and 2?
What about Q2?
Q2 and S1 and 2.
Okay, when you're asking me what about them, what exactly do you mean? Do you mean that could we use them to prove that QS is parallel to TP?
Yes, ma'am.
No, we couldn't in this situation, because when we want to prove that lines are parallel, either alternate angles are equal, corresponding angles are supplementary, as it is in this case, corresponding angles, co-interior angles are supplementary, corresponding angles are equal, right? So angle S1 and angle Q2 don't have a relationship with one another like that. They're not alternate. They're not co-interior. And the other thing that we also can't do in this situation, which, I mean, maybe if we went back and we looked at our statement over here, we could maybe bring proportionality intercept theorem into this. QR over, yeah, you see we can't, we don't have TQ. So yes, no, we wouldn't be able to do it in any other way. Here it would have to be because the corresponding angles are equal. Okay.
Okay, thank you.
Pleasure, pleasure. I hope you can see that. I know this is what we're dealing with now is certainly quite complex. All right, and then the last thing that we needed to do was prove that TQ was 1.5. Okay, so going back to, they told us that QR, if you remember this, we know that QR was 9,6. We know that TP is 4,5. We know that PS was 1,5. We know that, where are we? SR is 12. SQ is 4. And TS is 3.5. What have I missed? And TS is 3.5. No, 3,6. So now they want us to prove that TQ is 1,2. Remember now, matrix, we have proved that lines, let's use a different color, lines are parallel. Okay, what happens when we have a line drawn parallel to the third side of a triangle? What theorem can we apply? We spoke about it in our first lesson.
Line drawn parallel to the third side. Sorry.
Yes, otherwise known as proportionality. There we go, Swelly there. Proportionality intercept theorem. Can you see how that's now coming into this as well? Okay, now that we've proved that lines are parallel, now we can use proportionality intercept theorem inside triangle TRP. Okay, so I'm just rubbing the first thing out. Right? So if we go back, all right, and we remember proportionality intercept theorem, okay, we've got to make a proportion with the thing that we want in it, okay? So we want TQ. So there's TQ over here. So we've got TQ, we've got QR. We know that QS is parallel to TP. We've also got PS, and we've also got SR. So I would like someone to make me a proportion with TQ in it using the appropriate sides of the triangle, please.
RQ.
Okay, so Chad has said something. Okay, what are you saying? RQ?
RQ over TQ.
RT over TQ equals?
Sorry, ma'am. It's RQ over TQ.
RQ over TQ equals?
Equals RS over SP.
RS over SP. Let's just see what you've said, and then we'll compare that to what Chad has said. So you've said RQ. Okay, so RQ over TQ equals RS over SP. I like what you've said. Was that you, Spahle?
Yes, it was me.
Good. All right. Nice. Okay, now let's just have a look at what Chad said. Chad said TQ over QR equals PS over SR. Both of you are correct. Wonderful, Chad. Okay, excellent. So whether we say what Chad said or whether we say what Spitefully said, you are both correct. Okay, it doesn't matter where you put the TQ, all right? What would be easier, Spitefully, is that Chad has put TQ in the numerator, all right? So in this sense, he's just going to have to cross multiply in order to solve the unknown. But there is nothing wrong with what you have done. So now let's go ahead and solve this. But before we move on, what do I need to write next to this? I have to write proportionality, intercept, theorem. And then I have to remember to name the parallel lines. So I've got to say QS parallel to TP. Okay, so RQ is 9,6, yes? TQ is in the denominator. RS is 12. What are we looking for? SP is 1,5. Okay, so now we're going to have to cross multiply. So 12 TQ equals 9,6 times 1,5. And then we would have to say 9,6 times 1,5 divided by, whoopsie, by 12. And hopefully that gives us 1,2. I don't have my calculator with me. Can someone just check that I'm right, please? Is that right? Okay, thanks, Benedict. Okay. All right, so there we go. We've done that. What a monster question, hey? It's a really nice question for us to do because it shows you how the similarity, the grade 11 work, proving lines are parallel to one another, and then proportionality, intercept theorem, how it all comes together in one question. Did you enjoy that? Did you enjoy that question? Thanks, Chad. Is Chad the only one? What about the rest of you? Okay, Swelile. I hope so. Yes. Thanks, Benedict. Thanks, Karen. Thanks, Karabo. All right, so we've got half an hour left. 6 out of 10 enjoyed it. Yeah. Well, you know what's good news, Ayamide, is that after the beginning of November, if you don't want to, you never ever have to do maths ever again. My daughter's also in matric this year, and I keep telling her the same thing. So, yeah, if you don't want to, that's it. You don't ever have to do it again after this, but you just got to get through these final exams. All right. So it's one last year, absolutely. And then you've got so much to look forward to. Your whole future is in front of you. Okay, so let's, yay, look at that, it's dancing. It is, it's going to be absolutely amazing for you guys. All right, so let's see how far we can get in this particular question. This comes out of the 2019 paper. It was question 10.2. And they tell us that in the diagram, ST, so that's this line over here, here's ST, and VT are tangents to the circle at S and V respectively. Okay, so straight away, what does that mean? If ST and VT are tangents to the circle at S and V respectively, and they both originate at T, what is it telling us? What does it mean?
They're equal.
Well done. Yes. Reason?
Tangents from the same point.
Exactly. Okay, so tangents from the same point. Excellent. R is a point on the circle, so that's this one over here. And W is a point on the chord, RS, such that WT is parallel to RV. Okay, so they've given us parallel lines. So Rekhomeditswe is saying that S2 is equal to V3. Indeed. Good, Rekhomeditswe, 100%. Okay, because they're angles opposite equal sides. All right, because of the tangents from the same point. Nice, lovely connections here, guys. I'm super impressed. Where were we? All right, so WT parallel to RV. So why would they tell us that lines are parallel? They would tell us lines are parallel because they want us to use corresponding co-interior or alternate angles, more than likely corresponding and alternate, because those are the angles that are equal. Okay, SV and VW are drawn. Fine. WT intersects SV at K, and then it says let S2 be X. All right, now, very typical exam kind of question. Write down, with reasons, 3 other angles. I don't know if this is big. Is this big enough? Can you guys see it okay? I just trying to get everything on the page is sometimes quite difficult. Okay. Write down with reasons, 3 angles each equal to X. Hang on. Now that's kind of disappeared a little bit. Okay. So what do you think? What else equals X here? W2 says Chad. Okay, why? Why would it be W2, Chad? But, Chad, is WSTV cyclic?
No, ma'am,
No.
it's not. It's out of
Exactly.
cycle.
So if it was cyclic, then yes, but we haven't proved that it's cyclic yet. And we can't assume it's cyclic because we can't see a circle drawn through points W, S, T, and V. All right. So unfortunately, it is going to end up being W2, but only later on. Okay. We can't do that just yet. Okay. So W2, unfortunately, not yet. Anybody got another suggestion to make?
Me, ma'am.
Go for it. Swelly Claire, which one?
R, because of 10 chord.
Ah, good. I'm well impressed. Nice. Do the rest of you see that? Okay, tan chord. Lovely. All right, so R is equal to X because of tan chord theorem. Good. Okay, so R is equal to X as well. Nice job. Well done. Now, Timothy says, is SV a chord? Yes, Timothy, SV would be a chord. So can you see, Timothy, ST is a tangent, S and V are the points on the circle, and then follow the triangle, okay, to the circle. And then over here, you can see, just get rid of this thing that's irritating, that R is the angle in the alternate segment. Yes, Zanele. Okay, R is good. Okay, so that's one of them. Okay, what else?
Ma'am,
Yes,
ma'am.
Mihle. Yes, Mihle.
if angle R equals X, doesn't that make V3 also X?
V3. Yes, it does. Yes, it does. Good, Mihle. Well done. And the reason?
Tangents from the same point.
It's tan chord theorem. It's tan chord theorem. Okay, Mihle. Okay, so here is the angle in the alternate segment. Here's the angle between the tangent and the chord, and follow it to the circle. Okay, so because R is equal to V3, tan chord theorem, that means that V3 is also equal to X. So yes, V3 is also equal to X. Also tan chord theorem. Good. All right, now we just need, yes, Mihle.
Ma'am, so when
Yes.
tangents start at the same point, it doesn't mean that the angles are equal.
It does. So what we could have done here, I don't know, I think, let me just go back and have a look. In the chat, who was it? It was Rechomeditswe. That's who it was. Rechomeditswe said that S2 equals V3. All right. And she was quite right when she said that, right? S2 does equal V3 because ST equals TV, tangents from the same point. S2 equals V3 because they are angles opposite equal sides. So to be honest with you, stating that V3 is X, there's actually 2 reasons. Either we could say tan chord theorem because of R, Or we could say S2 is equal to V3 because of angles opposite equal sides. So if we wrote angles opposite equal sides here, we would also get a statement reason mark. Okay, so both reasons are true in this case. Does that make sense, Mihle?
Yes, ma'am.
Okay, lovely. All right. So which is the last angle matrix?
W3,
Look.
ma'am.
Which one's Swelihle?
W3, ma'am, because of
Oh, Swelihle, you are on fire.
corresponding.
Good, how much?
Pardon, ma'am?
Just say, what was your reason?
Corresponding.
Oh, that's beautiful. Oh, you're making me so warm and fuzzy inside right now. Okay, so corresponding angles, beautiful. Okay, do the rest of you see this? Okay, so this is what Swelihle was looking at. W3 over there, and then angle R over here. Okay, do you see the F lying on its side, matrix? Okay, so good. And now I've got to remember to name the parallel lines. So WT parallel to, what was this? RV, all right. Okay, done deal. Okay, so with each of those, it would be statement, reason, statement, reason, statement, reason. Okay, so that gives us 6 marks so far. Now, Chad, now we want to prove that WSTV is a cyclic quad. Okay, we know that that angle is X. Okay, so look at it from this perspective, Chad and everybody else, okay? Put your eyes at S and at T, okay? So if you could put your fingers at S and T and then follow S to W and T to W. S to W and T to W. Can you see that that angle is X? That's angle W3. Go back to ST. Now follow S to V and T to V. Can you see we're looking at angle V3? Can you guys see that? Yes, yes, okay, cool. All right, so fingers at S and T, okay? Follow S to W, follow T to W. We're looking at angle W3, which is X. Go back to S, go back to T. Fingers at S and T, follow the lines from S to V and from T to V. We're looking at angle V3. Okay, there we go. We have proved that WSTV is a cyclic quad already. All right, because V3 equals X and W3 equals X, WSTV has to be a cyclic quad. Reason? Converse. Angles in the same segment. Does that make sense? This is what we were talking about a little bit earlier. Okay, Benedict, no problem.
Ma'am, can you please explain how, because we don't have a cyclic quad?
Okay, so in other words, Bahle, you can prove that a quad is cyclic, which means that you basically, you're proving that it is possible to draw a circle through the 4 points S, T, V, and W, all right? What I was wanting you to do, all right, was to look at line ST over here, okay, and see how we can follow that to W3. Then if we back at ST again, if we come back here, my straight lines are appalling. Do you see the bow tie? The butterfly.
Oh, yes.
You see the butterfly, you see the bow tie. And then look here, this angle over here and that one over there are the same. All right, so that proves that the quad is cyclic. Does that make sense, Bahle?
Yes, it does, ma'am. Thank
Okay,
you.
so what we've got is V3. This is what we would write. We would write that V3 equals W3, because we've got V3 here, we've got W3 there, equals X. Okay, therefore, WSTV, let's just move, I'm just moving the chat out the way. Therefore, WSTV is cyclic, converse, angles in the same segment. Okay, and now we've got 6 marks, we've got 2 marks, we've at least got 8 marks. All right, how are we feeling? Maybe a little bit tired, but hopefully good. Thanks, Chad. Good, Swelile. Good, Chad. All right. Let's move on. Okay, I want to try and finish this question with you, and we've only got 15. Cool, Ayamide. Thank you very much. Cool, Swelile. Cool, Benedict. Thank you. Thanks for your responses. Okay, so now they want us to prove that WRV is isosceles. So I'm just going to get rid of these horrible purple lines that I've drawn in here. Okay, so now that we've proved that this quad is cyclic, we can use the fact that it's cyclic if we need to, all right? Okay, so if this angle over here equals that one over there, then if that angle is X, it also means that this angle over here will be equal to X. Now that we've proved that it's cyclic, now we can say, Chad, that W2 equals S2 because they are angles in the same segment. Now that we've proved that it's cyclic. All right, so WRV is isosceles, WRV. So that's this triangle over here. So when we prove that a triangle is isosceles, they are essentially asking us to prove that there are 2 sides that are equal to one another. Right? Which means there need to be 2 angles that are equal to one another. So what we've done now is we've said that angle W2 is equal to angle X as well, okay, because of angles in the same segment. And look here, guys, here we've got our Z. So that would be equal to X as well because of alternate angles. So now that I've proved that the quad is cyclic, I'm allowed to go angles in the same segment. So I go W2 equals X, angles in the same segment. Then I go V1 equals X, just move the chat out the way. V1, whoopsie. V1 equals X, sorry, just that out the way. V1 equals X alternate angles. And that is because WT is parallel to RV. So what this means is that angle W2 equals angle V1. No, sorry. That's not what's important here, even though that's true. We know that angle R is equal to X. So R equals X. And that was from 1.1 we proved above. So now we're going to conclude that angle R equals angle V1. Okay, I'm just going to have to move this up. Therefore, triangle WRV is isosceles. And that is because we have proved sides opposite equal. angles. How does that feel? I know I've kind of rushed through that a little bit. W1 and V1, Chad says W1 and V1. Okay, we don't know anything about W1 at this point, Chad. That's why I went with W2 and V1. Does that make sense, what I've done? Yes, total sense. Okay, oh, good. All right. So now that you prove that the quad is cyclic, angles in the same segment, so that means W2 is X. W2 is alternate to V1, so it's also X. We've already proved that R is X, so that means that R and V1 are the same. That means that WT, oh, why am I drawing lines there? So WT, in fact, what I should have probably done is concluded WR, so sorry here, pen. So that means that WR equals WV. Okay, so therefore WRV is isosceles, sides opposite equal angles. Okay, let's push on. And let's see if we can just try and finish this. Okay, so now back to similarity. Okay, easy question. They've told us which triangles are similar. They've given us the order, so they've given us lots of hints. Do we know anything about the lengths of any sides? In any of this information, do we know anything about the lengths of sides? No. Okay, so this cannot be corresponding sides in proportion. This has to be equiangular. All right, does that make sense? Okay, so good. Okay, so WRV is this triangle that we've just worked with over here, which I'm now highlighting in purple. And which other triangle? TSV. Okay, so again, I'm just going to get a bright color. TSV. Trying to draw straight lines on this Wacom board are not easy. All right, so again, this is not particularly difficult. Can you see we've got an angle X over here and we've got an angle X over there. And then we've got an angle X over here and an angle X over here. And then that means that W1 must be equal to the whole of angle T because of angle sum and triangle. So it's actually not a particularly difficult one to prove. Does that make sense to everybody? Again, angle W has to equal angle T, like we said, right? R equals S. R equals S. And V and V are the same, V1 and V2. Okay, so here we would write in triangle WRV and triangle TSV. Okay, so R equals S2 because they both equal X. That's the first point. Second point, V1 equals V3 again because they both equal X. Let's move this up. Okay, so therefore, last point. Okay, angle W1 has to be equal to angle SVT. Oh, sorry, angle TSTV like that. Remaining angles of a triangle or angle sum and triangle. Okay, so therefore, triangle WRV is similar to triangle TSV, angle, angle, angle. Yeah, no, it doesn't, Chad. It doesn't. So if you said that angle R was equal to angle V3 and that angle V1 was equal to angle S, it doesn't matter. It doesn't matter because they're both isosceles triangles. So in this case, no, it doesn't matter. Okay, good question. Thank you. All right, so now, pleasure. Okay, so now, last question. Let's smash this. Okay, and then we are done with prep for the exam when it comes to geometry. All right, so now the last question, guys. They've asked us to prove that RV over SR equals KV over 2S over TS. So what do we do when they've given us a proportion and we don't know which triangles to work in? What do we do?
Horizontal and vertical, ma'am.
Okay, so horizontal and vertical. Okay, we may need to replace a side here with work left to right. Okay, so here. All right. If we go left and right, we're asking ourselves, is RVK a triangle? Oh, well, can't really ask. Okay. So Benedict says no. Is RVK a triangle? No, it's not. Okay. So side and side didn't work, right? So there's no point looking at the bottom side and side because the top side and side doesn't work. Okay. Now, that doesn't work. Let's do round the outside. Okay. So now we're going to ask ourselves, is RSV a triangle? Is RSV? So RSV is a triangle, so that works. Is KV, okay, but now KVTS. KV, where's K? KVTS is not a triangle. So now we've seen a situation where side and side and around the outside does not work. If you end up in a situation like this, what you need to do is go back and have a look at what you can replace. There must be two sides that are equal to one another. So in this case over here, which sides were equal? Which side can we replace with which side? RV. Okay, so in other words, in this particular proportion that they have given us, right, we cannot make a triangle through side and side or around the outside. So that means that there is a line that we can replace. So in other words, if you have a look here, line ST, that's this one over here, ST, okay, ST is also equal to VT. So if I replace that with VT, so now again, this is my rough work. So now I've got RV over SR equals KV over VT because VT and TS are equal. Is RVK a triangle? Is RVK a triangle? No. Okay, so that still didn't work. Let's try. Is RVS a triangle? RVS is a triangle. Okay, so this here. Such a pity we have to race against the time. Okay, so that makes a triangle. Is KVT a triangle? Yes, it is. KVT is a triangle. Okay, so now we know in which triangles to work. Okay, so we've had to replace a side with an equal side and then try again, left and right or around the outside. Okay, now we know which triangles to work in. So again, I'm sorry, I know I'm rushing a little bit, okay? But to answer this question, this is what we're going to do, okay? In triangle RVS and triangle KVT. Okay, so RVS and KVT. So RVS okay, so RVS is this one. The yellow. Okay, and KVT is this one. Okay, well, we can see that this angle over here, V3, is equal to X and R is equal to X, right? So these angles over here are equal to one another. Let's just get rid of this color. Then I can see alternate angles. Can the rest of you see alternate angles? So in other words, this angle over here, K4, is equal to this angle over here, V1 and V2. Can you see that? So we would be able to prove that those triangles were similar to one another. All right, so very quickly, because we're running out of time. Okay, so in these two triangles, first point, okay, angle V3 equals angle R, both equal X. All right, angle KVR is equal to angle K4 because they are alternate angles, and that is because WT is parallel to RV. WT parallel to RV. All right, so the third and remaining angles of the triangle, so in this case, matrix, that would be S1 and T2. S1 and T2. Okay, angle, sum, and triangle. Okay, so therefore, triangle RVS is similar to triangle. Now we've got to get the order right. Okay, so angle R went with angle V. Okay, angle V went with angle K. And the last one, S and T, went together, so that goes over there. Angle, angle, angle. And now we would be able to do the corresponding sides in proportion. I'm sorry, Emily, I know I'm over. I just want to finish this, please, please, please. So first and last, second, first two, second two, first and last, corresponding sides in proportion. And now let's just go back and see what it was that they wanted. RVSR, RV, RV, come on, RV, SR, and KV and TS. KV, so KV was this one over here. Okay, and then if you remember, VT was equal to ST. Okay, so it is actually this one over here. So RV over VK equals RS over VT, but ST equals VT. So therefore, RV over VK equals RS over ST. Phew. Sorry, Matrix. I know that was a little bit of a rush to get that last one done. Just before, yes.
Ma'am, how do you know which, like when you said ST is equal to VT, how do you know that side is equal to that side?
Because I went back and I looked at what information I already had. So if I look at the proportion that I was given, all right, I don't know that RV is equal to any other side. All right. I don't know that SR is equal to any other side. I haven't proved that. I haven't come across that in the question. All right. I also don't know that KV is equal to another side, but I do know that TS has another side. TS, from the very beginning, I knew was equal to VT because they were tangents from the same point. So out of the four, it was the only one that had another side that was equal. Okay, so that's why in this case, all right, you look for that one that's got an equal side, you replace it, then you find the triangles, prove that they're similar, etc., like we had done before. Okay.
Okay,
all
ma'am.
right. Pleasure, pleasure, pleasure. How's everybody feeling? Apart from a little bit rushed at the very end. Good, Swelihle. I'm so glad. Everybody else? Good. Getting better. Very good. I'm so pleased, Karabo. Thanks, Chad. Good. Good, Rechumeditswe. Okay, if you don't feel good, it's okay for you to say that as well. But obviously, I do hope that you do. Okay, Spahle. Karen, thank you, Karen. Well done, Matrix. Thank you so much for interacting with me. Yes, you will continue to get better, Daneo. Just keep working hard, okay? It's not long to go now. You just got to hang in there. All right.
I'm going to jump in, Lee.
Yes, go for it.
Okay, cool. Hi, guys. I'm taking today for Coco. I just wanted to say well done. It was a very long session. And just remember, Matrix, a marathon, not a sprint. So make sure you look after yourselves and have a bit of a stretch now, because that was a long session.
It was.
If the grade 7s, I make them stand up and touch their toes. I won't do that with you guys. Okay, right. So just a quick look. So we're on lesson 4. We've finished triangles. Homework for today is on the app. It's under geometry, so pictomic geometry, and then under similarity, it's converse of the similarity theorem. Is that okay? Everybody got that? I don't know if you want to jot that down. Okay, you can also just search it in the bar at the top. Okay, then has everybody got the schedule? It is on the website if you need it. Today is the 27th of October, so we're up here, workshop number 4. Next is Saturday at 10 o'clock to 1 o'clock, analytical geometry.
Indeed.
Dokes, guys. Feel free to invite your friends and tell them about this grade 12 course. It's getting close, and we're nearly there. You guys are nearly finished. Yeah, that's everything for tonight. Good job, guys. Thank you. Thank you, ma'am.
Thank you. Well done, everybody. And if you've got questions on analytical geometry that you want to send to me before the time, you're welcome. Okay, you can just email them. Yes, Swelihle.
Sorry, ma'am, that was a mistake.
Oh, was it? Oh, okay. All right. All right. Never mind. Okay. All right. Night, Matrix. See you on Saturday. Bye.